Hi, my name is Ernesto Jr. and I'm a mechanical engineer. Today's lesson will be pulse width modulation. Pulse width modulation, or PWM, is a control technique used to generate analog signal using pulses from a digital source. Now we know that digital signal comes as high or low. In the demo that we'll be using, 5-volt signal as high or on and 0 volt as low or off. So why do we need to learn PWM? PWM is essentially useful in applications like control of heating elements, DC electric motor control, audio amplifiers, mechanical actuators like valves for digital scroll compressors, and UPS inverters. In this lesson, to illustrate pulse width modulation, we will use the Arduino de Villanova clone ACE2328 from Alexan, a 5-volt DC motor, connection cables, Arduino IDE 1.0, and a USB connection cable to the computer when we're uploading the code to the controller. Pulse width modulation has two components to define its behavior: duty cycle and frequency. The duty cycle describes the amount of time the signal is in a high state as a percentage of the total time it takes to complete one cycle. The frequency determines how fast the PWM completes a cycle. Now, if this sounds like big words to you, to illustrate simplistically, if a complete duty cycle is 10 seconds and 5-volt DC is available within 3 seconds, the effective voltage available is 3/10 times 5-volt DC, or in this case 1.5-volt DC. That made it simple, right? Within the Arduino clone, the duty cycle or percentage of time the signals or pulses are in a high state can be represented by a variable declared using the analog write method within the Arduino IDE. As you change that variable within a range of integers 0 to 255, you will be able to control the available effective percentage of power sent via the pin number 9, which is 5-volt DC. Here, we are showing you a demo using the ACE2328 with pin 9 delivering the PWM signal to the 5-volt DC motor, as the internal variable changes value from 0 to 255. The speed of motor goes from 0 to full speed. As the motor reaches full speed, the internal variable reverses its sign and from 255 goes back to 0, and the whole cycle starts all over again. Before we proceed with this, it is important that you go have a look at the Arduino CC website and understand how basic syntax works within the Arduino Sketch IDE. So what we're going to do now is set up 3 variables within Arduino Sketch as follows. First, the variable that declares the pin that sends the signal out to deliver 5-volt DC, in this case, pin 9. That variable is called motor pin. Second, the variable that represents the duty cycle, initialized at 0. Internally in Arduino, the range of this number is 0 to 255 and is proportionate to the duty cycle in sending the 5-volt DC pulses to the load side. We will call this variable mSpeed. Now the third variable is the incremental change of the duty cycle, that is, in how many steps the duty cycle changes. In this demo we're doing, we are using 2 increments at a time to increase or decrease the duty cycle. Since we are doing a demo using a motor, we will call that variable aptly as speed change. Now to actually send a signal out to a motor, we use the Arduino method pin mode and use pin 9 and output as parameters. You may be wondering what output does. The term output allows the Arduino recognize pin 9 is being used to send out the pulse. Next, we go to the loop where we change the duty cycles in steps using the method analog write and taking the variables motor pin and mSpeed as parameters we declared earlier. Every time the loop goes through, the mSpeed value, which represents the duty cycle, increases or decreases depending if the value of mSpeed has reached the minimum and maximum value allowed for within the range of 0 to 255. For the effects of change in duty cycle to be observable, we are using a delay of 70 milliseconds within the loop. This allows us to see a gradual change in speed of the motor we are using in this demo. Finally, we upload that code to the Arduino, and we'll see that we did it successfully. Now that covers PWM basics, and I hope this lesson will help you apply this control technique to real-life projects you encounter in your jobs and in your hobbies. Watch out for more lessons from me in the future. Thanks and have a wonderful day.